Okay, so I thought this has a GFI outlet and it has a 20 amp circuit breaker here. I thought maybe the breaker was popped out. Or maybe the GFI outlet was tripped, but it looks like it's okay. Now there's nothing, got no voltage. So we're going to have to pull this apart and see what's going on. So I'm just loosening each of these to make it easier to zip them all out. Notice how long these are? That's why I'm using my drill. Because I need to be able to get my meter on these wires and see what's going on. That's why I have to pull all the screws out, get everything taken apart. Okay. So this should be a fairly simple check. What I want to do, I need to test to see if I'm getting any voltage here. I need to see if the circuit breaker is functioning. And essentially, I'm going to see if there's any voltage coming out of the generator. Okay, the first thing I'm going to do is I'm going to test continuity on the circuit breaker, because that could be a problem. I doubt it. This thing has hardly seen any use. So go to continuity mode. Might have to pull these wires out of here. Got one there. Jeez. Okay, one there, and then one there. Okay, so that tells me the circuit breaker is good and it's closed. So now what we're going to do is we're going to start up the generator, and we are going to test the power across the outlet. Now I just had this running, so in theory it should start right up. Let's see. No? Okay. Not good. That means it's the generator. Because all these connections look fine. It's not the connections, it's not this. It is the generator. So that's another project here. It's not so good. Hopefully this comes right off. Although there are wires attached in here. Hopefully it's something as simple as a broken wire. But with me, it's never simple. All right. let's see what we have here. So we got all the wires are crimped together. That all looks good. We have a 20 microfarad capacitor in here. We're going to have to test that. I'm not seeing anything obviously wrong, so we will test the capacitor. Oh, well, there's definitely some corrosion on this terminal here. Oh yeah, look at that. I wonder if that's the problem. So let's take this and we'll do a capacitor check. So will this come out of here easily? Sure, comes right out. Okay. It doesn't look bad. A lot of times if these go bad, there'll be indications. But having a bad, rusty, horrible connector like that could be an issue. So we're going to go to capacitor test. And before we do anything else, you must discharge the capacitor. So I just happen to have a razor blade here on my bench. We're going to hold that on there for a second. And now we're going to just test it and make sure there's no voltage on here. And there is not. So now we can go to capacitor test. So that reads 20 microfarad. The capacitor is a 20 microfarad. So that means it's probably good. What I should do is a leakage test on this, but I don't think that's the problem. I think the problem may be nasty connection there. Let's see how bad this is. That is pretty bad. That's funny. One of them looks okay, the other one does not. All right, what I'm going to have to do is I'm going to cut this one plug off and put a new connector on there, because that's no good the way it is. The capacitor is rated at 20 microfarads at 425 volts. So we will set the meter to 400 volts. To the 400 volt range. We're on the aluminum electrolytic side. And now we're going to do a value check. And we're reading right exactly 20.1 microfarad. So that is extremely close. Now we're going to do the leakage test. And we are reading 0 microamps leakage, which is good. That means the capacitor is good. Turn this back to low voltage. And that way the next person that uses the meter doesn't accidentally shock themselves. I'm not sure if I said this already, but the capacitor is a problem. That bad connection, it's a problem. It may not be the problem, but we can't proceed until we fix this. I'm going to replace both of these because they're essentially junk. Okay. The one didn't look bad, but this other one is completely junk. So whenever you put on connectors, always twist the wire strands together. That is good practice to do that. Okay. I'm going to get my connector lined up right in the middle of the barrel. And then we'll put one in here. Okay. And we crimp. Like it if I could crimp that a little bit better here. Let's see. That one. Okay. I'll do the same to this one. Getting that right in the middle of the the connector barrel where it crimps on. Okay, so now I'll put one here. I'll put one here. This other side doesn't look so hot either on the back, but it was making a connection. There, okay. So now I'll put our capacitor back in its little zip tie holder here. And then we're going to start this up again and see what we have. Hopefully we have voltage. Hey, what do you know? 126 volts. So it was the capacitor that was the problem. Okay, great. I think I'm going to blob some, I'm going to put some no locks on these connectors just to give them a little bit of protection. Okay, I'm just going to put a little blob of goop on these things. It's not a major deal, but yeah, I'm just going to put a little blob of grease on this, and that'll kind of protect them from weather. Hopefully that'll protect them and not let that happen again. Okay, now that that's back together, I'm going to plug my drill in, and let's see if it works now.